In this video we will find for what value of parameter a greater than 1 does equation a to x equal x have a single real solution. To solve the problem we will consider first how many solutions can this equation have at different a. We will use graphical analysis, and first we consider the functions which represent left and right hand side of this equation. And these functions are this one and this one. Let's first sketch the plots for this function. We select relatively large a, then the y increases relatively quick, then we decrease a. In this case, the growth of the function is not so quick, so we have, for example, 3 cases. A decreases in this direction. At the same time, the right-hand side is represented by the straight line for all cases, and this straight line makes with horizontal axis the angle 45 degrees. Next, we will combine these two plots for each case separately. So we plot the straight line for right hand side and plot one graph for left hand side, which corresponds to large A. There is no point of intersection of these two lines. It means that the left hand side and right hand side are never equal. So in this case, this equation has no solutions. Then we consider second case. Again, this is our straight line. Here is a plot of left hand side, and in this case the straight line is a tangent to the black line, and this point, which we denote as x0, is a root of this equation, single root. The third case, again we plot straight line for right hand side and the curve corresponding to a to x. In this case there are 2 points of intersection, so we have one solution here and one solution here. So in this case, this equation has 2 solutions. Now we will find parameter a for the case of single solution of our equation. We denote this value as a0 and return to our plot, and we can see that at this point, corresponding to x0, the y-coordinate for the straight line and for the black curve is the same. So we have the first equation for a and x0. To find the second equation, we will take into account that the slope of red line and black line at this point are equal. The slope of black line is a derivative of this function with respect to x, and this derivative is equal to this value. The slope of straight line is again derivative of this equation with respect to x, and it is 1. At this point, these 2 slopes are equal, so we replace here x with x0, and we have the second equation for a0 and x0. Now we combine these 2 equations into the system, and we will solve the system for a0 and x0. First, we replace this term with x0. Next, we find from this equation x0. Then we plug in x0 to equation 2, and we will find equation which doesn't contain x0. To solve it, we take a logarithm from the left and right hand sides. On the right we have ln 1, which is 0. On the left we replace logarithm of product with the sum of logarithms. So we will have two terms. Next, we will use the property of logarithm, and we get this equation. Now, here we have logarithm a0, and here the same logarithm. So they are cancelled, and we have at this place we have 1. Now this equation can be transformed to this form, and we should find a0. How to do this? First, we will find ln a0, and this is equal e to negative 1, or 1 over e. And then we find a0 as e to power 1 over e. So actually this is a solution of the problem, but in addition to a0 we can find x0. So we take this logarithm and plug in this equation. So we replace this ln with 1 over e, and we have for x0 the simple answer. Now we can calculate this value and write the answer in this form, or in this form. In conclusion, we may say that equation which we considered at a from this interval has two roots. a0 is given here. At a equal a0 has one root, and at a greater than a0 there is no roots. On the right you can see graphical illustrations of each of these cases. If you like this video, you may want to click like button, leave a comment, and subscribe for the channel.